Okay, I think we're here. We have two people in the chat. Looks like the little poll question is 50-50 on have you modeled some parts that you ended up printing or not. So one person did, one person hadn't. Maybe some other people will join later on. You can't do the chat if it's not live. So, or wait, yeah, you can't do the live chat anyway. You have to do post chat, I guess. But what we're going to do today is talk through some different modeling techniques for not necessarily just for 3D printing, but some stuff that other than the fusions and the SolidWorks and things like that, where it's a little more meant for mechanical type part production, although you could do that and then print those parts on your printer possibly. We did have a video a couple of days ago about printing stronger parts, functional parts. We'll follow up on that too, because I mentioned some things about like hardware that you can include in the print. So we'll print one of those and show how that works too. And before we do our stuff, I'm going to show you a couple of things. So let's go over here. This is giant. Oh, it's still stuck to the base. Giant vase here. Let's see. Whoops, upside down. Probably 7.5 inch tall vase. So remember, we changed out the nozzle to a 0.8 because I didn't have the 0.6. Technically a 0.8 should be able to go down to 0.2 millimeter layer height, which is kind of the normal one I print at. I don't tend to print very thin layers unless I want high detail. And then if I want high detail, I probably am sending it to a resin printer to get that kind of detail out of it. So this 1 hour prints all of this. Now this is a special type of print where it's hollow, right? So it's only one wall thick, which is pretty pretty strong steel in this case, because our walls are 0.8 millimeters thick, size of the nozzle. There is one issue though. Remember, when we changed that nozzle, I sliced a couple of things and looked at their flow rates in Cura, and I think this one does suffer from inadequate flow, kind of like right in there. You can even see on the monitor, you can kind of see some of the ripples. Those are, it's too thin. It's kind of pulsing on that surface. There's another one there. So it is leaving gaps in there. You can't really, I can tell in person like it's much thinner. I don't know. Maybe you can see down in there. I don't think you can see the issue down in there, but you can see the stripes. If you can see them in person, there are actually you can hear it. See that it's really thin right there, and a couple of those surfaces I see. That one, and that one, all in the same area, and they're all these extreme overhang type things. It didn't provide enough flow, plus combined with the fact that that's like a 45-degree overhang, so there's not a lot of overlap between the adjacent layers. Those were not sufficient. This little error right here, can you see it? Yeah, that little error, that is me, like, while it's printing, trying to see the flow rate, and I kind of jostled it around. But other than that, like, most of the layers are actually really clean. So we probably, if I wanted to do it again, I don't know why, but if I wanted to print this thing again, then I would slow down the print speed a little bit, because I was printing at 215, so I could probably go up to 220 and get a little more flow out of it. But I'd probably slow it down. I was at 50 millimeters a second, which is already kind of slow. But I could go down to maybe 45 or so to try and help those couple of layers survive a little better. It did survive. It's not watertight by any means, but do have a giant vase now in an hour. So that's one of the benefits of the large nozzle, is that you can print relatively quickly. Now that one's also a vase mode. We haven't talked about that, but it's really only just one wall, so those are going to print faster anyway. Here, this is, well, these two filament samples here that we're going to work on next. So this one, the green one, is a TPU. So it's super floppy, kind of rubbery. I actually have one, I don't see it right now, that's even softer than this that we may not be able to print. But you can print this kind of material on just your regular Ender 3. So the idea here is that when you finish the print, it is a rubbery, soft, flexible print. And sometimes that's useful. If you were watching last time, we talked about printing RC planes. Some of those plane parts were printed in a material, probably not this green color, but in a TPU material like that, so that maybe like the tires on the landing gear, or some flexible coupling somewhere. So you can print flexible materials. So we'll print that. You don't have to make any changes to your printer to do that. And then I want to get to printing something like this. So this is carbon fiber field. So there are lots of different carbon fiber PLA, PETG, blah, blah, blah. This one is polycarbonate. So we may not be able to print this on a regular Ender 3, as you certainly could not on a regular Ender 3 that you haven't changed the nozzle. So we've changed our nozzle to a hardened steel nozzle. So a brass nozzle, you could print it, but it's going to eat up the brass nozzle pretty quickly. Maybe not this amount. You know, I only have, what, 16 meters of it. But if you were printing a roll, then yeah, it would eat up the nozzle before the roll is over. But that's not even the real issue. You can change the nozzle out. The real issue on this is that the minimum temperature it wants to print at, I don't know if you can see that, but is 240 degrees Celsius. So we can get our Ender 3 to 240. The problem is that that's about the limit of what you can do. So for two reasons. One is your firmware probably has that as the limit. It won't let you heat it more than that. But even if you overrode that, so you overrode that limit, the issue is inside the nozzle, or not the nozzle, but inside the hot end, there is a Teflon tube that's lining the inside part of your hot end. We'll take, I'm looking at the outline, looks like next class we're going to take a hot end apart so you can see all the parts. But that tube will start to melt at 240-ish degrees Celsius. So we will have to change out to what's called an all-metal hot end. You would think you already have all metal. The nozzle's metal, the heat break, the heat block, the heat sink, they're all metal. But inside there is a Teflon tube. And so we would need a type of printer that does not have that Teflon tube in it, or a type of nozzle in hot end. And we can do that. I actually think I have one over here that we can sub out, but 240 we can do. That's just the minimum printing temperature. It also says it wants the bed at 100, which this bed out in the open is going to have a hard time getting to 100, but we're going to try. We do have our, super bed weld, so maybe that'll help. It does not say that polycarbonate is one of the ones that it's supporting, but we'll give it a try and see if on a regular Ender 3 with a hardened nozzle, so you would have to have that if you want the nozzle to survive anyway, can we print this carbon fiber polycarbonate material? I'm not sure. I know we can get it to print if we change out a couple of things, but can we get it to print without changing stuff? I don't know. Well, that's what's upcoming in some of those. We're going to do the TPU first because it's really straightforward, and then we're going to try to move into some of this more difficult to print material. All right. Now, what we're actually going to talk about today. I've got, if we go over to our outline here, I've got Meshmixer, Genie, and some other stuff, random things. Let's look at Genie first. So Genie, if I click on this, it's from lumalabs.ai. Let's see if I can get it not covering the whole screen. Actually, you can't see the prompt. This is a what would you call it? It's a AI powered geometry generator. That's what I'm going to call it. I'm just trying to get it to fit on the screen in a reasonable fashion. It's kind of Maybe that'll work. All right. So what it does is these pictures in the background, those are all supposedly AI generated prompts. So like, I don't, you can click on them. This is, the prompt was wooden wolf carving with ruby gemstone eyes carved 4K. And it generated this wolf carved head thing. Here's a skull with horns on it. Oh, a horned animal skull. Here's a croissant, realistic croissant. Here's a large cactus in a white pot, minimal spikes. So we're gonna throw, oh, what is this alien one? Cell shaded alien, cute, Pixar, big eyes, and quirky. So kind of a Mike Wazowski type of thing, but AI generated. So we're gonna create our own thing. We don't want a wall. Let's see, what should we try here? Maybe we'll do something that fits in, or that what I'm going to do after this is we're going to go to Meshmixer and take some existing meshes, so STL geometry files, and we will try to mix them together into a new thing. So maybe we'll try to get something here that will match with those. Let's see. I've got a couple of little models already selected in Thingiverse that we're going to use. Let's say a a lantern. Lantern for let's do realistic lantern. We won't do a whole lot other than that. Let's just see what happens if we create. So first, it gives you like 4 little low resolution previews, options that you can choose from. Sometimes it takes 30 seconds to a minute. Oh, there we go. These look not so bad. I don't want a wall mounted one. I want one like this that looks like it would be relatively straightforward to print. Obviously the little thin handle's not going to print very well. That one looks okay. That one looks okay. Let's just go with this one. All right, so I picked my variation that I like. It's, you know, it's not perfect. It's kind of wobbly, but that, and the, you know, the inside part here is really messed up. Let's try to apologize at a high resolution. We can export as a couple of different things. Let's just do an OBJ. OBJ is like an STL file, except it has colors built into it. So if we just did STL, we would get just the geometry, which is fine too. That's all we need. Let's make it high resolution. And although we're going to make it really small, so this is probably fine, but let's see what happens if we make high resolution. I don't know how long that's going to take though. It says a couple of minutes, so we'll come back later to check on this. But as far as I can tell, this is free to some extent. I'm sure there's a paid version or something like that where you can go in and get more performance out of this thing. And there will be more and more of these types of pieces of software, AI powered stuff out there. This is just the first one I ran across that actually generates sort of decent geometry. It's never smooth like hard edges and stuff like that. I haven't seen any models that come out looking like something out of SolidWorks or Fusion 360. It doesn't really generate that kind of model, but maybe this will work because this is going to be pretty small when we use it. All right. So we'll let it do its thing and kind of run in the background. So that was Genie from Luma Labs. We'll skip this online sculpting tool for the time being, and we'll go into Meshmixer. So Meshmixer is kind of a, it's free. It is an Autodesk product, so you might have to have an Autodesk account, which is also free. But this one's fully functional, but it hasn't been updated in years, so I assume this link still works. No, okay, that's fine. We can go to meshmixer.com. So 2021 is the last update, but that wasn't even an update to Meshmixer, it's just an announcement. So what they're saying is that Fusion from Autodesk contains many of the things that Meshmixer can do. So They don't plan to retire Meshmixer, but it's not being developed anymore. But it still has quite a few things that it does that I don't want to get all of Fusion 360 running just to do a couple of things. So I tend to still use Meshmixer. It looks, yeah, you can still download it, and it shouldn't be, yeah, it's Windows 3.5 installer here. Well, not Windows 3.5, Meshmixer 3.5 for Windows. It says Windows 7 or later. That's kind of how old this thing is. But it still works in principle. So we're going to fire, actually I already have Meshmixer running right here. So here's kind of what you get when you start a Meshmixer session. You can create geometry straight from here, like from primitives. There are, I'd have to start, you know, a new file or start from a sphere or a plane or something like that. We're going to start from existing geometry that somebody else has made or scanned or however they created it, and then we're going to mix a couple of things together. So I went to Thingiverse over here, and I started searching for some little models that we want to modify them and put them together. So found this guy, so a little skeleton. He's got a sword, and I said, why don't we replace his sword with a mace? So I found a model of a mace. Hopefully, actually, now that I'm looking at it, this is just the connector. That's not what I want. I need an actual mace. Let's find a different one. That's just not the mace itself. I don't want one like that. There's a whole bunch of weapons. We could have. We could just do a club, I suppose. That might be fine. Let's find. Yeah, we'll just get that club. It should be. Oh, it's a set of all these weapons. We can make that work, I think. All right, so we'll grab the club from there, and then instead of, he was on a little flat rectangular base, we're going to put him on a round rocky base. So we've got all these pieces, and we could just print them out and kind of like cut things away and glue them together. But Meshmixer, one of the things that I use it for anyway, is for taking existing geometry, whether you made it yourself or you found it on Thingiverse or you scanned something from the real world in. We'll talk about doing that in, I don't know, a couple of weeks or lessons anyway. But it's taking all those things and putting them together in one new file, and you've got this new thing now. Let's see. Let's also check on our. It still says it's going, so I don't know. We'll see what happens there. Let's download all of our little guys. So file, we're going to download him, and we're going to get these weapons, and we're going to get our round base. Thingiverse is one of the older, maybe the oldest currently active site where you can just go and get STL files. Most of the stuff on Thingiverse is meant for 3D printing. Some of it's not, some of it's laser cutting, but most of it's 3D printing, and it can be anything. So, and it's all free, so you don't have to pay for them. There are other sites like this, Printables. Bamboo Lab has a version. I don't remember what theirs is called right now. I'd have to find it. But they have a Maker Creator or something like that that has the same type. Usually it's the same files that are on all three of these big sites where you can download things. There are, if you just want to print some stuff and you want a really specific nice model, there are some paid sites, Cults 3D, Game Body. There's some of these where you can get some really nice models to print, but they're usually not free. So these others, Thingiverse, Printables, and whatever the Bamboo Lab, those are free. You can use a donation usually. I think, yeah, you can tip the designer if you really like using whatever they're using. You can give them a little tip. We've got our files downloaded. That thing still says it's working. I wonder if I close it, if it will still. I don't know. That kind of looks like it just stopped doing anything. Maybe we'll just download this guy. It's going to be tiny. It'll be fine. So it does say it's going to clean it. So we'll see what that means. I don't know how long that's going to take either. So let's let it do that. I did ask it to retopologize, which means that these OBJs and STL files are made up of triangles. And so retopologize kind of goes back and tries to arrange the triangles in a way where none of them are really like long and skinny type of triangles. They're more regular looking triangles. And so it's trying to do that and trying to create a nicer mesh of triangles. I don't know how long that's going to take though. All right, let's go over here. I think probably let's import our skeleton first. So he should be in downloads. There he is. So so one thing about Meshmixer is it doesn't really give you a scale. Like I don't know how big this guy is. You know, he's just here. So everything's going to be relative. And then when we get him into Cura or whatever we're going to slice, that's where we'll scale for a certain height. So first of all, why don't we chop off this rectangular base? We could just add the lumpy circular base, I suppose, and weld them together. But just so we can see how to chop something off. Actually, we need to chop this sword off because we want to give him a what you call it, a club. So we can go into select, and there is a lasso where we can just go in there and kind of, whoops, I missed a piece. We can just highlight some stuff, check around that nothing we don't want is highlighted, and hit delete. And then let's get this little piece out too. Now that did leave a hole here, so we'll clear our selection. And over here in the analysis, there's an inspector, and it'll recognize, hey, there's a giant hole right there, and there's some little issues that it's not sure about over here. You can tell it to repair everything, and now that's closed in the hole there. Actually, I kind of want to clean up that a little bit. Let's try and get rid of, see if we can get rid of some of these other triangles. You know, and you can be more or less picky about how much time you want to spend on this thing. We're being pretty not picky. Let's go ahead and, since we're working on, we got rid of the sword, we still left the pommel of the sword there. We'll just leave that. That'll look like part of the club. Let's go and import. We're going to, we don't want to replace our skeleton. We want to append to our skeleton. We want to append the weapons. All right. So it was saying that those things are gigantic compared to what you currently have. You sure you want them that size? And I said no, and it scaled them. Actually, it scaled it pretty close to the right size, you know. Maybe it needs to be a little bit larger, but not that much. The only problem is there's a whole bunch of them. So we're going to edit this model. You can select your different models over in this object browser. So we're going to be on the zombie weapons. We're going to edit that, and we're going to, let's transform it so that we can move it off to the side. That looks good. And then let's do the same thing we did before, where let's just erase the stuff we don't want. So I don't want those, and I don't want those. There was a mace right there, but I've already, oh, I inverted it. Whoops. Control Z. Oh, that reminds me of one thing. So Meshmixer, like I said, it's an old piece of software. It's not being developed any longer, and it can get unstable. So it is not a bad idea to save relatively often. I'm just going to save this on the desktop, and we'll just call it Summer 2024 so I know what it is. Because particularly if you get lots of triangles, so a really complicated model in here, it can decide to just crash on you with no coming back from it. I actually don't want that one. Clear the selection. I want the other side. I'm not sure why it won't let me select this part. I want this one. Is there an invert? There we go. So there was an invert button. Delete those. Now we just have a club. All right. It looks pretty much the right size. Let us edit the club and transform it. And then you get this little gizmo here for, you know, trying to move it around. So sometimes that part can be a little tricky to try and get it all tilted around exactly the way you want it. I am not going to be super particular here. I'm just going to try to get close. You know, that looks like a good size and pretty well lined up. So we'll accept that. Now if I select both of these over here, so hold down Shift and select, now I get a new set of options. Boolean union, that just adds them together. Gives me a little preview. Do you like that? Accept. And there are other things you can, there are options here. I'm not going to go through max quality or some of these to make it a more perfect match just because they take longer to do. So I'm just going to go with this. It looks decent. Oh, see, there you go. So unknown fatal error has occurred. It didn't actually crash though, so that's not too bad. Let's try again. Now let's actually just try, I did Boolean union again. And let's do fast approximate. See if that'll, nope, doesn't like that. Let's see if just combine will work. So that worked well enough. We just combined them together. And now they are one file over here. All right. So let's see about cutting this bottom off here. So we can do that the way we were doing, but there's also, in analysis, there's also a plane cut. Not analysis, in edit. There's a plane cut, and we can just drop that down to somewhere there. And you can discard half, keep both halves, and just split them apart. A couple of different things. You can remesh the open area that's going to be cut away. So this looks good, and it's keeping the half that I want and throwing away the other half. So it looks like I left a tiny bit of surface there. We could try to get rid of that. It'll cut off some of his toes. Nope, still didn't get it. All right, there he goes. So we got that. Let's go import our little circular base. We're going to, again, append. And I think that's this one. Looks too large, right? So we're going to have to scale that down. So let's select it and edit it. Transform. For one, let's try to get it kind of in the right spot. And then let's scale it. So I'm clicking on that smaller little cube in the center there. And that will scale everything uniformly to get it kind of the right diameter. Maybe something like that. We need a place for he's kind of, you know, his foot's kind of in that area. This one looks okay. That one's kind of part of the thing. We could spin it around a little bit, maybe to find a better spot. Not too bad right there. We'll accept that. Now, over here, we've got a little issue, like the rock is part of his foot now. It's like he's part of it. We could just leave that, for one thing, just leave it the way it is. But there's other tools, there are other tools in here, these sculpting tools. So I've got my base selected over here. And I can go to sculpt. And then what I get are a set of tools that treat the model like clay. So I could just drag, and then I could, this little sphere is kind of the area of influence, and I can just kind of drag the rock out of the way, you know. it's not affecting his leg because his leg is not selected. It's only the base that's selected right now. So I can kind of, you know, move that around. Maybe make it a little small, not weaker, smaller, so that I can get, oh, that didn't look good. Control Z is your friend in this thing, because a lot of times you are editing and then you didn't like what you made. I do want to also think that I want to 3D print this, so I don't want any severe overhangs. It looks like that's fine. If it's a little, remember this is going to be like that size, so it's not like I need a whole lot of worry on all these little details. But now his foot's not part of that rock. This one looks fine already. Oh no, look, he's floating above it a little bit. So let's go back to our edit, transform, and let's move so that they're actually connected together. There's a little bit of stuff there, so let's move that off of his foot. Again, not being too worried here about what happens. That angle looks like it could print without support, so we'll leave that. Let's see if our, alright, looks like I can download. So now I've got this zip file. I'm going to go over and extract that to see what that came out like, because I don't know. So let's see if we can import our newly found or created lantern. I assume this is it with the crazy name. And there's its OBJ file. Much smaller, so it's going to scale it up. Alright, so scaled it up kind of weird, but it's there. So let's work on it. Let's edit, transform. Let's get it kind of the right way. It's got to be way smaller if it's going to be a lantern that this guy could hold. Maybe even smaller than that. And where could we attach this? Maybe we'll just set it somewhere. He doesn't really have any free hand right now, so maybe we can get it to kind of lay right in there somewhere. So it's just kind of a little feature. Now this little part definitely not going to print very well. We could try to erase that possibly. So if we select, we could get rid of that handle. Probably get rid of that little piece right there. Get rid of that piece. We've cut some holes in it. We'll fix that later. I don't know if I can get that. That one's going to be hard to select. Maybe we'll just let that one fail and it'll be fine. It's a broken up lantern, so if it doesn't print that great, that's fine. Run our inspector to fill in the holes. Now we've got a totally new thing that didn't exist before. One other thing that we can do, so maybe you want to you wanted it just the way it was before, but you want them in different poses. So you can also, let's go to select our skeleton guy, and maybe we want to, what's a good part of him to repose? He's kind of all connected together, but maybe we just want to make his, he's connected to his leg. There's the problem. What can we do? Maybe we can turn his head a little bit. So we can go in and let me remember this, edit. Actually, maybe we need to select first. So let's try and select his head. Uh-oh, I ran out of room. We'll clear selection and do that again. Oh, select. Now, one thing it's going to do is it's going to select, you know, this behind him. So So I probably need, maybe that angle would select better, because I could go around there. Still got a couple of his collarbone pieces. There's a way that we can modify our selection, but what I want to do right now is this modify, which is, oh no, deform, which is, actually I wonder if I can clear. There's a way I can unselect. I just don't remember if it's, oh, it's control and then just drive over the ones you don't want. So hold down control and you can deselect. All right, so now his head is selected. Deform and then smooth. Oh no, whoops, not smooth. Deform, soft transform. Smooth actually smoothed out all the stuff in all those triangles. And then I get a new gizmo and I can like why is it not letting me? It's not actually deforming. All right, so he's selected. Well, I actually don't know why it didn't. Normally you can modify, like you can actually rotate items, but for some reason it was not letting me do that. I'm painting on the selection to see if that makes any difference this time. I'm on the correct thing. I wonder if all of them have to be combined together. I don't think they do, but we're going to combine them just in case. Oops. That's not what we wanted. Let's just get something. Okay, so maybe there was some reason why it wasn't doing that, because they weren't all combined together into one model. So let's go back and select what we actually want. So I wanted to rotate his head around a little bit, not for any reason other than to show you that you can do it. So Meshmixer, what I use it for anyway, is for if you have some model that you need to combine two things together, and all you have are the STL files. So typically, now they're getting better, but typically SolidWorks, Fusion 360, those don't work too well with STL files. They can, but they don't work very well with them. And so Meshmixer, it doesn't mind them at all. It's fine. It can combine them with OBJ files and all kind of stuff like that. And it generally works pretty well. But some of these other programs that are more engineering focused, they are not too good with can't get the ones I want. They're not too good with STL files. So if I have only the STL file and I need to change it somehow, Meshmixer is usually where I go. So now if we wanted to, it added some to our selection a little bit because I did the soft transform instead of just the regular transform. But see, we can make him look a different direction without too much disruption in distorting the model anywhere. So now he's looking more straight at us instead of looking over his shield. So you can modify, you can add things together. We can export this thing now. So if we did, now everything's in one model. We can file, save as. Oh wait, no, it's export. not save as is the Meshmixer file, but we can export and we can get a STL or OBJ, a couple other ones. We would want STL. You'll notice there's STL, ASCII, and binary. Those don't matter. What an STL file is it's just the location of the vertices for all the triangles that make up the geometry. So sometimes the binary one is a smaller file type. So we'll call him skeleton. And then we can take him to Cura, which I have open. There's our giant vase that we printed. Oh, you can also see, I was looking at the flow rate, and it does look like it was 12 millimeter cubed per second, and for most of the vase, and apparently it just couldn't keep up in a couple of places. All right, so let's go back to here, get rid of the vase, and let's open our skeleton. I think I put him on the desktop. Oh no, I saw him in there. Oh, there he is. Okay. So there he is. It looks like, I think these are 10 millimeter blocks on here. So if we click on him, his club actually goes outside of that base a little bit. Let's just look at his height. So he's currently 32.5 millimeters tall from very tip of his head to the base here. That's reasonable. That's reasonable size, not too bad. Now, he's not going to... This is a thing that might happen to... Oh, it says it's got some errors. I think that's okay. We'll see if... a lot of the slicers can fix those kind of errors. If I slice him, though, he's probably going to look really weird. So, that looks crazy, right? Two things are happening here. One, this line out here, like, why is there a line connecting these two things? I am currently in vase mode because I just printed, wherever I put it, I printed that giant vase, and I printed it. It's kind of under my picture over here, or here. I printed it in spiralize outer contour mode, which only does one perimeter, no matter what you do. So that's good for vases and things that only need one wall and nothing on the inside, but not good for solid models. So I'm going to unselect spiralize outer contours, slice him again. He's still going to be kind of like very abstract, right? Because I am currently at a point. Let me move the picture out of the way. There we go. I'm currently at a 0.6. Oh, that's what I can do. I don't know if I'll ever get that in the right spot. 0.6 millimeter layer height, which is way too thick for this guy. So let's go to 0.2. 28 minutes, that's not too bad. I'm in the flow rate thing, so let's go off of flow and just look at line type. We'll show all the white little dots here are the start of a layer. I've got infill, which if I scroll down through him, infill's in green. I've got the shell or the outer perimeters in red. There's some top and bottom layers down there. Sometimes I look at the color scheme by line type, but material color's fine. There we go. So he's kind of going to look like that. That's reasonable. It does... Oh, it did, for some reason... Look at that. It did say that it's not going to print the club connected to the rest of the hand there. So what could be the issue there is that little section could be so thin that the slicer can't actually resolve it. So if you end up with something like that, there is a in your slicer there's a thin wall. Let's see if I can find it. Print thin walls. So it could be that that area is just so thin. Remember, I've got this giant nozzle on here now, and it's so thin that it can't resolve that thin of a area. So one thing I could do is I could go back to Meshmixer and beef up the handle of the club, which is probably a better idea because it's probably going to break if it's so thin. But this will also happen if you've embossed text on an item and you want it to print that text. Sometimes the text is too thin and it won't, the slicer can't pick it up. So you click print thin walls, reslice, and it'll force it to try and print something. And it did. It printed, you know, something in there to connect the club to the rest of the model. Again, these little figures like this probably are not going to come out too well with a 0.8 millimeter nozzle. In fact, if you print these little things, normally you're thinking, oh, I'm going to go from a 0.4, that's the default nozzle size, down to a 0.2 or a 0.3 millimeter nozzle. So you're going the opposite direction of what we did. We could scale him up though. So we could say that, what if we made him 200% scale? Now it's going to take longer. That was, I think, like 30 minutes to print that guy. Now he's starting to look a little more, now he's gigantic compared to other models that would be this kind of thing. But he's all there. What we'd have to worry about here is, if we go to prepare, all these red, oh, this base was hollow. I didn't even notice that. That's weird. That's probably why it was having issues before. So I didn't notice that it was hollow. All these red areas are areas where the slicer thinks it would need support material. Surprisingly, there aren't many, and I don't think they even bother that much. Maybe under his pelvis here, that would be a little droopy, and under his rib cage, but he's a skeleton, so if he's raggedy, it's probably okay. If you do need support materials on a model, you know, a complicated model like this, there's a better option than the default support. So default support would look like this. It'll take longer to slice to figure out the where all the supports go. 2 hours, nearly 3 hours. So the default is kind of all these little blocky things. Sometimes for a model that has all these little ins and outs, the support can be trapped to where you can't get it out without breaking something. So a better option for a lot of times, it might take longer, but a better option is, one, you could just say, I only want support touching the build plate. So it doesn't build support off of the model like it did right here. So this support is built on top of the model to hold up part of his hand. You could do that. That might help in some cases. But this one doesn't have... I typed in tree up here, and now I've got the support structure. Normal is what we just had with the rectangular columns. Tree supports are like vines that grow up the model. So let's slice it with tree supports. It'll probably take even longer to slice now, and it might even take longer to print. But the idea with tree supports is they're way more organic, and they will kind of wrap around the model and branch up to touch, well, you can kind of see, branch up to touch just the places. Now I've got a really large gap between the support and the model right here. There's probably too much gap. You can modify that gap. Not in these settings. But if we go back to support So I don't have all the support options that I want. So if I hover over the support label, I get this little set of sliders, and that will let me choose other options that I can put. Remember, I'm in like the basic settings or whatever. So here are some of the, let's do the support structure. That'll let me turn on tree supports. But there's also Z distance. So that's how far away the support is from the model. And right now it must be kind of thick because I've got a 0.8 millimeter nozzle in there, I guess. That's why it made it so thick. But there's a lot of these others that I could turn all, there's a bunch of them. So I've got the support distance is actually only at 0.2, but it looks way more than that. Looks like it's way more than 0.2 in the preview. Like it's not even really doing anything. But these supports, actually it was faster to print, and these supports might be easier to remove. So again, this is a larger scaled model. If we scaled him back down to his regular size, then it might get a little fiddly to remove some of the supports. I'll try printing this on a printer that still has a 0.4 millimeter nozzle so that we can see what he comes out looking like. I am a little bit worried about the thinness of his club. One thing you can do for these models to try and make them a little more durable is in your, so let's look at his insides. He's still mostly hollow, right? So one thing you can do is in your top layers, I'm set to 3, just set it to like 1,000 so that everything's a top layer. And that will that will create a dense model. Take way longer to print, obviously, but that could strengthen them up. And again, this is double-sized model. He's 200%. So what I'm going to do is I'm going to slice him. It's not that long though, 3 hours and 19 minutes. But when I scroll through him now, he's solid everywhere. But it's not an infill. The tree supports are not solid. That's the circles you're seeing. But he'll be a lot stronger. And there's a bunch of support underneath it because this base was kind of hollow. I probably will go back into Meshmixer and make that base not hollow, because that's I don't know why it needs to be hollow. Maybe these were weighted or something. I don't know why they were hollow like that. So I'll print him on a 0.4 millimeter nozzle, regular size, so we can see him next time to see how he comes out, because it's probably going to take a couple of hours. But we went through the Meshmixer software, not all of its features. It can actually generate support. It can do some auto arranging of models to see what their optimum printing position is. It can do a lot of things like that. But the main things I use it for are to meld different models, STL models together, or to reposition something. So just kind of tweak it a little bit. I also had, let's see, there's Luma. There's our little Luma deal. We'll go back over here. I also had this online sculpting tool. So Fusion 360, what else is that? Onshape, SolidWorks, FreeCAD. Those softwares are meant for hard edge modeling, parametric modeling. You've got, actually FreeCAD may not have a very good tree history to it. I can't remember now, but they're meant for more engineering type of work. You can use them in other ways, but they're kind of meant for more engineering type work. But there's another set of software, or at least one other set. There's actually several types of software, but there's another set of software that is meant for almost the opposite of that. It can do stuff that you would print for an engineering type purpose, but it's really meant for like a very organic type of modeling. So ZBrush, Mudbox, and then this free online tool is the one I've got here. if we click on this, it just opens a web browser, and all of it just operates in the web browser. And what you see in the front there is a digital ball of clay, and so it works like the Meshmixer sculpting tools, except that this is a little bit more refined, all free, but there are paid versions of this type of software, particularly ZBrush and Mudbox, that are even more powerful. Those are the things that animators use to create CGI type creations for movies and things like that, video games and all that. But this is a simplified version of that same kind of idea. So you've got, a set of brushes similar to what you would have in a program like ZBrush or Mudbox, just for free. Actually, ZBrush, let me go to it real quick. There is a free, not just a free trial, but there is a free version. I can't remember what it's called. Let's see. But, Groot, things like that are made in programs like ZBrush. So you get really high detail, assuming you can actually sculpt that well. You can do hard edge type modeling in these. It's just not quite the same as you would do in SolidWorks or Fusion 360. But there is one that's not just a free trial. I don't remember, and I don't see it right now. But there is a version of this that is kind of simplified down a little bit. But, there are also some Forger and ZBrush for iPad. There are some of these that you can use on tablets. But the idea with these is, you've got your tool. I think I'm on a move. Let's do a move tool. So you can have symmetry, so you can kind of see the two little dots there, and you can, move things around, and you can, I'm sure there's shortcut keys, maybe not, I don't know. Let's make that not so gigantic. And wait. There we go. Oh, that's a masking tool, so I can mask out different areas so that they don't get affected by the whatever brush I'm using. Let's see, I don't know. Let's do the move again. So, you can do different things. So you can make all sorts of very organic shapes. You can add more blobs. You can keep editing this one. You can retopologize it. You would have to watch a whole lot of tutorials on how you do all this kind of stuff. But there's a whole separate suite of software that is not just, drawing a sketch and extruding it and making a cut hole or a revolution or, that type of approach. There's a whole set that's meant for more organic type modeling. And then there's a couple that are in between. Probably the most popular in-between piece of software is Blender. Blender.org here. I guess I need to put its link in the class description there. Totally free, and it sits somewhere between a hard edge modeler like SolidWorks and Fusion and a pure organic modeler like ZBrush and Mudbox and that online sculpting tool. So it can do kind of some of both, and it's completely free. It does have a pretty steep learning curve. I think we will use it a little bit. I'll give just a demo of it. I don't have time today to do the demo, but I'll give a demo of Blender later on. We're going to do some scanning, like LiDAR scanning, and use that real-world geometry to make some prints also, but there just won't be time for doing that today. But Blender, let's go ahead and put it in our list of software over here. Actually, it's over here, isn't it? Here. we'll put it in here so you have it as another option. So these are all different ways that you could go. Oh, I need to add a line. You could go and create some geometry. There we go. There are plenty of these too. These are some of the more popular ones that you'll run into. The Blender in particular is, you'll hear people all the time say they use Blender. It's like I said, it's somewhere in between. It's kind of a middle of the road. The thing about it is that it's free to use. I think it's also open source, so if you are capable, you can create your own API plugin type things for it to do what you want to do with it. I think it's open source. I don't actually remember if it is. It doesn't say it's open source anymore. Maybe not. Anyway, those are some different ways. Oh, there's some chess. Ways that you can create. You can just download things, add them together. You can sort of create some geometry just from a prompt. Or you could create this geometry from a prompt and then take it to one of these other pieces of software and edit it to clean it up or to make it exactly the way you wanted it. Maybe remove that handle so it's easier to print, that sort of thing. I still think Meshmixer is a useful piece of software, even however many years later it is now. It looks like the last one was 2018 was its last release. So still pretty useful piece of software. The Sculpt GL is a interesting thing to play around with, particularly if you have a tablet computer that you can use a pen on. You can use a mouse. This is a mouse right here. You can use a mouse to use it, but if you have a pen-based system, then these sculpting type programs are a little more intuitive to use then. So hopefully something in there at least gives you some new ideas on other things you can do other than just always go into SolidWorks or Fusion or Onshape or one of those pieces of software that are more traditional for engineering. We will certainly use those plenty for parts that we want to make that are more functional, but you don't always have to make functional parts. All right, next time, what are we at next time? Next time should be Monday. It should be a live stream, and oh yeah, we're looking like we're gonna, I'll probably combine these two. I don't know if the whole class will just be looking at a hot end, although it might be a hot end replacement, because we wanted to print, we wanted to print this stuff that is the 240 degree to 280 degrees Celsius. Although I want to try it on a regular ender first with a hardened nozzle to see if it's even doable that way. And then we'll do the replacement. All right. I'll see y'all Monday, and hope y'all have a good weekend.